Welcome students. In the last class we had discussed about the electrical actuators and we have covered the switching devices, that is mechanical switches, solenoids, relays, and the drive systems. In drive system first we covered the DC motors. So basically we have discussed the four types of DC motors. Okay, so now we will go to the alternating current, that is AC motors. Okay, alternating current motors, AC motors. So AC motor is basically two types. Okay, one is your single phase and second one is your polyphase. Okay, polyphase means it can be a three phase. Okay, single phase, in single phase and polyphase both are classified into another two subgroups, that is your induction type and synchronous type. Means ultimately one can say an AC motor is a induction type single phase AC motor or synchronous type single phase AC motor. Okay, if you go to the multi phase, suppose you are using the three phase, so it can be a induction type three phase AC motor or synchronous type three phase AC motor. Okay, so let's discuss one by one. First is your single phase motors tends to be used for low power transmissions or low power requirements, where the polyphase motors are used for higher powers. Okay, so what is the basic difference between single phase and polyphase is that single phase motors are used for low power requirements. If you are using the polyphase, it is used for high powers. And if the cost will come into picture, then induction motors tends to be more cheaper as compared to the synchronous motors, and mostly in industry and in various applications you are using the induction motors as compared to the synchronous. Why? Because it is lightly less cost. Okay, so second one, if one can discuss the what is single phase. So let's the single phase squirrel cage induction motors consist of a squirrel cage rotor. Okay, and this can be a copper or aluminum brass that fit into the slots in the end rings to form the complete electric circuit. Okay, so material is copper or aluminum bars. Okay, there are no external electrical connections to the rotor. Okay, the basic motor consists of this rotor. Okay, this squirrel cage rotor with a starter having a n number of windings or a set of windings. Okay, when the alternating current passes through this starter, okay, starter means this starter windings, and you know from the Faraday laws of electromagnetic induction, an EMF, that is AC current passes means an AC EMF means alternating magnetic field will be generated. Okay, is produced as a result of electromagnetic induction. An EMF is induced in the conductors of the rotors and currents flow into the rotor. Okay, and current flow into the rotor. Okay, simple concept. It means you are supplying the AC voltage. As AC voltage you are supplying means alternating magnetic field will produced. As the alternating magnetic field is produced, it will generate a electromagnetic induction or EMF. Okay, and this EMF will create the current that will flow in the rotor. Initially, when the rotor is at rest or stationary, the forces, okay, on the current carrying conductors of the rotor, look here, of the rotor in the magnetic field of the starter are such as to result in no net torque. The motor is not self-starting. Okay, the rotor rotates at a speed that is determined by the frequency of the alternating current applied to the starter. Okay, for a constant frequency supply to a two pole single phase motor, the magnetic field will alternate at this frequency. So this speed of rotation of magnetic field is termed as synchronous speed. Okay, the rotor will never quite match this frequency of rotation, so typically differing from it by about 1 to 3%. So this difference is called as your slip. Okay, now come to the 3-phase induction motor. I have already clarified you that 3-phase means it will be used for high power requirements. Okay, so the 3-phase induction motors is similar to the single phase induction motor, but has a starter with 3 windings, and the windings are connected or located at 180-degree apart. 120-degree apart from each other, means total is 360 degree, circle is 360 degree. There are 3 phase, means each winding will be located at equal angle. That equal angle will be 360 degree divided by 3 is your 120-degree apart, and each winding is connected to one of the 3 lines of this supply. Okay, this supply because the 3 phases reach their maximum currents at different times, the magnetic field can be considered to rotate around the starter poles, and this completing one rotation in one full cycle of the current. Okay, now you can see here. Okay, another I am reading that line, because the 3 phase reach their maximum currents at different times. Okay, the magnetic field can be considered to rotate round the starter poles, and it completes one rotation in one full cycle of the current. Okay, but one thing you remember, the 3-phase motor is self-starting, but the single phase motor is not self-starting. Okay, now come to the synchronous motor. The synchronous motors have starters that is similar to those of induction motors, but a rotor which is a permanent magnet. Here synchronous motor means one special difference is that we are using a simple permanent magnet. Okay, the magnetic field produced by the starter rotates, and so the magnet rotates along with it. Okay, what happens then, with one pair of poles per phase of the supply, the magnetic field rotates through 360 degree. Okay, 360 degree in one cycle of the supply, and so the frequency of rotation with this arrangement is the same as the frequency of the supply. They are not self-starting as compared to the similar to the single phase induction motor. They are not self-starting, and some system has to be incorporated to start them. Okay, so students, this is all about your drive motions. One is your DC motor and another is your AC motor. In the next class you will discuss a special type of DC motor, that is stepper motor and the servo motors. Okay, and servo motors are 2 types, that is your DC servo motor and AC servo motor, and then this third unit will be completed. Thank you.